Okay, we're going to finish out with dilations. Dilation is just an enlargement or a reduction. You can blow it up or shrink it down, however you want to think about it. The formula for dilations, there's a couple ways to do dilations, but if the center of dilation is at the origin, like the pattern down here says with the origin, then this is all you have to do. You have to take your x and y point values and you have to multiply it by the scale factor. So what I mean by that is take your x value, times it by the scale factor. That's what SF stands for. So if it was a scale factor of 2, you would double it. If your scale factor was a half, you would cut that number in half. That's all you would have to do for a dilation. So let's practice that, and then I'll show you another way that they might ask for a dilation. Remember, we said at the very beginning of this video that a dilation can be an enlargement or a reduction. And so if you have a reduction, that means that your scale factor is less than 1, but greater than 0. So it can be a negative number. Negative changes it to a reflection or something like that. So less than 1, like 1/2, 2/3, a fourth, things like that. If you're going to enlarge a figure, then that means your scale factor was greater than 1. So looking here, we see that the center of dilation is at the origin, so we can use our pattern here. We know our scale factor is 2, so let me show you a couple ways you can do this. Let's go ahead and write down where A is. We can see that point A is at -2, 3. Point B is at 1, 2, 3, 1, 2, 3, 4, 5. Let's call it 4, 5. I know it's off just a little bit, but we'll just go ahead and say that it's at the 5. And then C is at 1, 2, 3, 4, up 2. Okay, so if your scale factor is 2 and origin is your center of dilation, all we have to literally do is take all of these numbers and double them. So if point A is at -2, 3, and I double it, it's now at -4, 6. That's all you have to do there. So -4, 6, 1, 2, 3, 4, 4, 5, 6. Point A is right here, and when you finish out B and C, you will see the enlargement of that triangle. Now, look at example 2. It says we're using point B as our center of dilation, which means B is not going to move. And we can't use our pattern here, so we have to use what's called using slope. And notice they put it in quotations, and I'll show you how that works. So we're going to move point A and point C, but B is going to stay at 0.45. That's not going to change. So let me zoom in here. Do you see how to go from B to A, we would go down 2, so down 2, over to the left, 1, 2, 3, 4, 5. So down 2, left 5. That's kind of what we're thinking of in terms of slope here. Down 2, left 5. Well, since our scale factor is 2, we have to show that twice. And we've already done it once, so we're going to do it again. Down 2, left 5, 1, 2, 3, 4, 5. And that is where A prime would be. Then we can do the same thing for C. Let me change colors here. We would go right 1, down 1, 2, 3. So think of that as your slope there. So because our scale factor is 2, we have to do it a second time. Right 1, down 1, 2, 3. And there's where C prime would be. So you can see that they perfectly line up. And we can see that our figure was enlarged. It was doubled. And so there's where our new coordinates are. So A prime is now at -7, 1. And C prime is at 5, -1. So if your origin is your center of dilation, you can just double your numbers or triple your numbers, whatever your scale factor is, multiply it by the scale factor. If it's a point, then you have to use our slope trick. So let's look at 2 more examples here. One together, one I'll kind of get you started on and you can finish it out. So if we look here, there's no graph. We see that the origin is our center of dilation, so all we have to do is multiply by our scale factor, which our scale factor is 2/3. So that means we're going to take all 3 of these points. So I'm just writing them down. and we're going to multiply every single number by 2/3. So here we go. Let me do one of them with you, and then you can finish it out. Well, multiplying by 0 is pretty easy. If we multiply 3 times 2/3, multiply like this. 3 times the numerator, 2, so 6 divided by the denominator, 3, gets me back to a 2. Okay, I'll just go ahead and finish this one out with you. We've already multiplied 3 times 2/3, so just bring that down. Now we can multiply the 6. 6 times 2 is 12, divided by 3 is 4. C prime, we've already multiplied 6, and we've already multiplied the 0, and that's where your dilated triangle would end up. And we know that it would be a smaller triangle. It would be reduced down because your scale factor is less than 1. All right, the last one is a review question, and it is kind of getting you to put a couple of things together. And so I'd like for you to try it out and see if you can do it. You're going to rotate 90 degrees counterclockwise. Let's actually change that to clockwise so that you can practice your pattern. So mark that out and put clockwise there. And then I want you to reflect it across the y-axis. So 2 transformations. You're going to rotate it 90 degrees clockwise. So graph your points, rotate it, graph it, and then reflect it across the y-axis. So you can do a couple of things. You can use your graph solely to do the rotation and the reflection, or you can write down your coordinates and do the patterns. That's up to you. But I do want you to try that out, and then you can come back and check your answer once you finish.